+7, +4, +2. And we decide to use a stock system. When there's more than one charge, you have to identify which metal version you have. You have manganese +7, manganese 4, manganese 2. And many of those transition elements are found, or those multivalent elements are found in the transition metal groups 3 to 12. Not all of these elements are multivalent, but many are. And there's some that are not quite in the groups 3 to 12. So for example, if you take a look at, let's say, tin, it's +2, +4, but it's not in group 3 to 12. That can also be multivalent. So for multivalent elements, you need to make sure that you identify which ones you're dealing with in the compound, the +2 version, the +4 version, if there's a +1 version, if there's a +2 version, a +6 version, +5 version, you have to identify it. You don't have to do that for the monovalent because they only have one charge. So lithium only has +1. You don't have to say it's lithium 1. That's just redundant. There's only one lithium there. If you have one student with the only name, let's say only one student is named Alex in your classroom, you don't have to say the last name because there's only one Alex in the classroom. So only use the stock system method. And the next method we're learning today, when you have multivalent elements, you need to recognize those multivalent elements. Today we're learning something called the Latin system, or the classical system. We're going to see how to name elements that are multivalent in binary ionic compounds using the Latin system. And so the Latin system will not use Roman numerals. Instead, it'll use two different endings, the OUS and the IC. Usually, you're going to be choosing between two valences, a low one and a high one. So iron would have +2 or +3, for example. So iron can be +2 and +3. If you had +3 in your compound, you would name iron with an ic ending. But if you had +2 in the compound, you would name iron with an OUS ending, because the OUS is a lower valence of the two and the ic is a higher valence of the two. So ic for high, us for low. So we'll do a practice problem together. So we'll do Hg2O. Hg is a multivalent metal. If I gave you the formula, you'd have to figure out, well, which Hg you have. So you can do the reverse crisscross. When you do the reverse crisscross, you get Hg +1, O -2. So if I asked you to name this using the stock system, you could say this is mercury 1 oxide. And we know it's 1 because the oxygen is -2. But now I'm going to ask you to name this using the Latin-based system, or the classical system, we call it. So let's go take a look at our periodic table. If you look at mercury, there's two possible charges, +2 and +1. The lowest being +1, the highest being +2. We have mercury 1, the lower valence. So since it's a lower valence, we're going to write mercury oxide, but we're going to replace the ending of mercury with mercurous to indicate that we have the lower valence mercury in this compound. So it's mercurous oxide. If we had the other compound, HgO, and you do the reverse crisscross, the story would be a little bit different. So let's scroll down. So assume I have HgO. Do the reverse crisscross, put the ones there on your subscripts, reverse crisscross it. You'll get Hg +1, plus because it's a metal, O -1. You know that O is not -1, it should be -2, so you multiply everything by 2 since it was divided by 2. And you get Hg +2 O minus 2. So this would instead be called mercuric, because the higher of the two valences, the +1 versus -1, mercuric oxide. And again, you could have also done the charge balancing method to figure out which one you had. So the main difference here is that rather than using Roman numerals like you did in the stock system, you're just changing the ending based on what your charge is. Ik for the higher valence of the two metals, and Us for the lower valence. So now we're going to try going the other direction. We're going to try to take a name and convert it into a formula. And our name is going to be the Latin-based name. So here we used mercury. And you notice that we used the prefix mercure from mercury. It makes sense. Now some of the elements actually will be named based on their Latin name. So for example, iron will not be ironic. It will not be ironis. Rather, we're going to employ the Latin name ferrum. Now you can see where the Fe comes from in iron. It comes from ferrum. Now you can see where the Au comes from in gold. It comes from aurum. So suppose we had ferric nitride. What you know is that this is the higher of the two valences because it's Ik. So you go into your periodic table and you find out what the higher of the two valences is. That's +3, not +2. So now you can write your symbols for the ions side by side. Fe +3, N -1, N -3. If you did charge balancing, you'd be done already. You'd see that there's one Fe, one N. They already make 0, so you'd have Fen. If you do crisscross, you have to do your crisscross. You get Fe3, N3, and then you have to reduce because it's ionic. If, on the other hand, your compound was ferrous nitride, you'd have a bit of a different story. So if we had ferrous nitride, you know you have the lower valence, which is not +3, but +2. So instead, you'd be doing Fe +2, N, 3 minus, crisscross, and you get F, E, 3, N, 2. In this case, you could not reduce, so you'd leave it as is. You could have also done the charge balancing method for this one as well. If you have Fe +2 and N -3, you want to get overall this to be equal to 0. Right now you're in the negatives. +2 and -3 is -1. So let's add in positive. We get Fe +2. Again, this is +4 total, +2, +2, -3. That's going to be +1. So now we're in the positive. So we have to add negative to balance this out. Then we have -6 + 4. So now we're in the negatives again. So we have to add a positive. Now we have +6 because of all my 2's and -6 because of my -3's there. That's an overall 0 charge. And that took us 3 irons, which is what I have here, and 2 nitrides, which is what I have here. So in this video, we saw how to name and write formulas when we're dealing with the Latin system or the classical system. You should become familiar with the Latin-based names. Remember the Latin-based names when you're naming these types of compounds.